Hello! In this video, we are going to prove the following theorem. Suppose a is a real number, and xn is a sequence of real numbers, such that xn is equal to a for all positive integers n. Then, the limit of xn is equal to a. So really, the sequence we're working with is a constant sequence, where every term in the sequence is equal to a. And we want to show that this sequence converges to a. Now, by definition, what does it mean for our sequence to converge to a? It means for every epsilon greater than 0, there exists a positive integer k such that for all positive integers n greater than or equal to k, the absolute value of xn minus a is less than epsilon. So to prove this, we're really trying to prove this statement. And since we're trying to prove a statement about every epsilon greater than 0, give me an arbitrary epsilon greater than 0. And from here, we want to find a positive integer k, which makes this statement turn out true. Now, if you think about it, every positive integer is going to make this statement turn out true. So, for example, let's show that 1 makes this statement turn out true. So we'll take k to be 1. With this choice of k, we're going to show for all positive integers n greater than or equal to k, the absolute value of xn minus a is less than epsilon. So since we're trying to prove a statement about every positive integer greater than or equal to k, give me an arbitrary positive integer greater than or equal to k. I'll call it n. And from here, we want to show that this inequality is true. Now, to do that, let's first note, since this statement is true, we know that this statement works for every positive integer. So it must work for the positive integer n that we have in our proof. So taking n to be the n we have in our proof, we have that xn is equal to a. And now we can show that this inequality is true. Let me start off by writing the left-hand side of the inequality. Now, since xn is equal to a, we can substitute xn for a. And a minus a gives us 0, and the absolute value of 0 is just 0. But we know that 0 is less than epsilon. So what we've shown here is the absolute value of xn minus a is less than epsilon. Exactly what we wanted to show. Now let's put this together. We see that under the assumption n is greater than or equal to k, it follows that the absolute value of xn minus a is less than epsilon. Since n was arbitrary, this means we've shown for all positive integers n greater than or equal to k, the absolute value of xn minus a is less than epsilon. So we have found a positive integer, which makes this statement turn out true. So this is true. And we proved that this statement was true under the assumption of some arbitrary epsilon greater than 0. Since epsilon was arbitrary, this means we have shown for all epsilon greater than 0, this is true. So we've proven this entire statement, which means we have proven that xn converges to a. And that's exactly what we wanted to prove, so this completes the proof. Now, when dealing with constant sequences, for example, in this case, our sequence xn is a constant sequence, where every term in the sequence is equal to a. We'll typically denote that sequence like this, rather than saying xn where xn is equal to a for all positive integers, right? This indicates precisely that this statement is true, right? So this is just a constant sequence where every term in the sequence is equal to a, and the limit as n approaches infinity of a is equal to a, right? So just for notational purposes, right? And so yeah, that's pretty much it for this video.